Hi everyone, we're starting video 13, which is on rational exponents and rational exponents or fractional indices. And what we're going to be looking at is we're going to be looking at powers, but instead of being raised to whole numbers, they were going to be raised to the powers of fractions. Alright, so we're going to be looking at section 2E from the MYP4 book and section 16B from the MYP5 book. So, like I said, in earlier lessons what we did was we looked at the laws of the indices and how they are true for whole indices or integral indices, so whole numbers or exponents. Now what we're going to do is we're going to look at the value of n, our exponent, but when it's a fraction or a rational number. And so, for example, if we have a to the 1/2 multiplied by a to the 1/2, what we need to keep in mind is that all the rules that we learned, so all the laws that were learned, and there were about 8 of them more or less, all those laws still apply even though we are dealing with fractions as exponents. So for example, if I were looking at this question right here, question number 1, then I would say a to the 1/2 times a to the 1/2, well, they have the same base on them, so therefore I'm using the a to the m times a to the n, which equals a to the m plus n rule, and that means that I would be just multiplying, I would be just adding my exponents together, so that I would get a to the 1/2 plus 1/2. Okay, so we're adding the two exponents together, where it would just go to a to the 1, which is simply a. The same thing would occur if we were looking at, for example, number 2, a to the 5/3 divided by a to the 4/3. So here again, we're using the rule a to the m divided by a to the n, which gives us a to the m minus n. And therefore, what I'm really doing is I'm saying a to the 5/3 minus 4/3, and that gives us a to the power of 1/3. Now, we can do just a few more examples here, which should be very easy to finish. So that a to the 1/3 times a to the 1/3 will give me a to the 2/3, and if I've got a to the 8 to the 2/3 times 8 to the 4/3, well, 4 plus 2 will give me 8 to the 6/3, but 6/3 really is the same thing as saying 2, so it becomes 8 squared, and if we really wanted to simplify this, it would go to 8 squared is 64. Now, if we want to look at y to the 2/5 times y to the 3/5, again, it'll be y to the 2/5 plus 3/5, which gives us 5/5, and that's equal to just y to the power of 1, which we all know to be just y. And I'll just do the next two very quickly. X to the 3/5 divided by x to the 1/5, so because it's division, we are subtracting our exponents, and therefore we have x to the 3 minus 1, which is 2/5. And then the last one would be 2 to the 3/4 divided by 2 to the 2/4, or 1/2, and that would give us 2 to the 1/4. Okay, so that would be taking care of the first part. Now, if we look at our next rule, so we're going to be doing these rule by rule. If we look at our next rule, this is the power to a power rule, where the power to the power rule tells us that we are going to be multiplying our powers together. So when I do a to the 1/2, all raised to the power of 2/3, that'll give us a to the 2/6. So 1 times 2 is 2, 2 times 3 is 6. Now, because I've got 2/6 as my exponent, but 2/6 can be reduced down, and when I reduce that down to its simplest form, it goes to 1/3. And all I've done was I've divided both top and bottom here. I've divided both top and bottom by 3. So by 2. So it's divide by 2, and I end up getting 2 divided by 2 is 1, 6 divided by 2 is 3. So if I take a look at the next example, so a to the 1/2 raised to the power of 2, that gives us a to the 2/2, which is just equal to a. Okay, now the one rule that we need to take a look at is how do we go from having an exponent, okay, so we have a power or an exponent, and we get rid of that power or the exponent. Well, the rule that we want to look at is this new rule here, which tells us that if we have a raised to the power of 1 over n, So a raised to the power of 1 over n, it's raised to a fraction. Well, what it actually means is that we are going to be taking the nth root of a, which will then, in this case, be raised to the power of 1. Okay, so if I had x to the 1/2, that would be like saying the square root of 2 raised, the square root of x, or the root 2 of x raised to the power of 1, and that's just equal to the root of x. If I had a raised to the power of 1/5, that means I'm taking the 5th root of a, which is then raised to the power of 1, and that's just the 5th root of a. If I had y to the power of 1/4, then it would be the 4th root of y, and that would be raised to the power of 1. So that would be just the root of y, and it's the 4th root of y. Okay, so the general rule then is, now we looked at all situations in this previous page where we always had 1 as our numerator in the exponent. So that anything, so if I had a to the 1 over 36, that would mean that it would be the 36th root of a. If I had x to the power of 1/8, it would mean that it's the 8th root of a. And if I had z to the power of 1/10, well, that would mean that it was the 10th root of z. All right, and that should be x over here, by the way, not a. All right, so that if I now look at a situation, though, where my fraction doesn't have a 1 in the numerator, but it actually has another number, so my value of the m in that exponent, or in the numerator of that exponent, is not equal to 1 anymore, then what we can be looking at is we can be looking at taking the cube root of 27 and then raising it to the power of 2. If I take the 8 raised to the power of 2/3, it's like saying the cube root of 8 raised to the power of 2. And if I looked at 100, for example, raised to the power of 1.5, well, 100 raised to the power of 1.5 really could be rewritten as 3 over 2, because 3 over 2 is 1.5. So it would be like saying the square root of 100 raised to the power of 3. Now, all of these situations, all three of these, can actually be simplified. And they can be simplified whereby I can say the cube root of 27, well, the cube root means what number multiplied by itself 3 times gives me 27. So the number that gives me 27 3 times is going to be 3. And when I take that value of 3 and I square it, it goes to 9. Same thing occurs down here in the next one. I'm saying what number, for the cube root of 8, I'm saying what number raised to the power of 3 is going to give me 8. And that happens to be 2 cubed. And so that ends up being, is 2 cubed. It would be 2. 2 cubed would give me 8. And now because that 2 is now squared, it would go to 4. And now the same thing occurs down here. What number multiplied by itself gives me 100? Well, that would be 10. But then when I take that value of 10 and raise it to the power of 3, it goes to 1,000. Okay, so the general rule then is we can, again, I can do a couple of more examples here. So a couple of more examples could be something like along the lines of, what about 16 raised to the power of 3/4? Okay, so 16 raised to the power of 3/4 means that I am taking the 4th root of 16 and I'm raising it to the power of 3. Well, the 4th root of 16 is referring to what number multiplied by itself 4 times is going to give me 16. Well, that number will be 2 times 2 times 2 times 2, so the number is 2. And then that value of 2 will be raised to the power of 3, which gives us a value of 8. So we have evaluated here. We have evaluated, or we have actually solved. Okay? All right, now, suppose I have, though, a to the power of negative m over n. Well, the same rule applies as a to the negative n that we saw in the previous lessons. We put it over 1 and it becomes a positive exponent. The only difference now is that I've got a fraction that I'm carrying down to the denominator. So for example, if I've got 27 to the negative 1/3, it's really like saying 1 over 27 to the power of 1/3. Now, that then is going to be rewritten as 1 over the cube root of 27 raised to the power of 1, and that gives me 1 over, again, what number multiplied by itself 3 times gives me 27? Well, that would be 3 times 3 times 3. So the value is 3. And because that all gets raised to the power of 1, the answer is just 1/3. Okay, let's try one more here. 4 to the power of 1/2. Well, 4 to the power of 1/2 is like saying the square root of 4 raised to the power of 1, and that tells me that what number multiplied by itself twice gives me 4? Well, that would be 2, and 2 raised to the power of 1 just gives me 2. Now let's do an example here of a power to a power rule. So a power to a power rule here gives us, we have two fractions, and in the power to a power rule, I am multiplying my exponents together. So technically, I could put my answer down here as a to the power of 24 over 60, and then I could reduce that down. So I could reduce that down, and let's see, I could divide by 6. So if I divide by 6, or maybe I could divide by 12. Let's divide by 12. If I then divide this by 12, the top and bottom, divide by 12, I would end up getting a to the power of 2 fifths. Now, a quicker way that I would do this problem, so this would be one way of approaching it. The quicker way that I would do this is I would cross out, where possible, I would use elimination, and I would get rid of whatever it's possible to get rid of first. So I would say 3 goes into 3 once, 3 goes into 15 5 times, 4 goes into 4 once, and 4 goes into 8 twice. Now when I do 1 times 2, it gives me a to the power of 1 times 2 is 2, and 1 times 5 is 5 for my denominator. You see that I still have the same answer. I've just taken a different approach to it, where I reduced down all the numbers before I actually multiplied, so that way I wouldn't have to do any simplification at the end of the problem. Now, if I have a question similar to the last one that I have here on this page, 3 to the power of 3 times a to the power of 2/3 divided by a to the 1/2. Well, I've got, again, I can look at it this way, 3a to the power of 2/3 divided by a to the 1/2. So what I'm actually doing is I'm saying 3 divided by 1 is 3, and now 2/3 minus 1/2. So 2/3 minus 1/2 is going to require that I get a common denominator, because I cannot subtract those without having a common denominator. Everything we've done so far has a common denominator to it. So I would have to write it as 3a to the 2/3 is the same thing as saying 4 over 6 minus 3 over 6. So I got a common denominator of 6, and when I subtract 4 minus 3, it goes to 1. So it's 1/6. So my final answer would be 3a to the power of 1/6. All right. One more problem that we can work on is we'll do another power to a power rule, so that I will do a to the 1/3 raised to the power of 3/4, and that's multiplied by b to the 2/5, which is also multiplied, which is also going to be multiplied to the power of 3/4. Okay? So that, again, I can choose to just either multiply everything through here, so I get a over 3/12, a over 3/12 times b 6 over 20, but then I'm going to have to bring those down, so it'll go to a to the 1/4 and b divided by, let's divide this by 2, it'll go to 3/10. Now, if I had done this problem by reducing it down first, I would have had, so just to show you, I could have done 3 and 3 cancel themselves out. So I have here a to the 1/4, and then I could have canceled out the 2 with the 4 here, and it would have been b to the 3/10. Again, I'm getting exactly the same answer. I just made my life a little bit easier by simplifying it a bit. Okay. Now, the next question here on page 9, it says to express the following using rational indices. So what it's asking you to do is it's asking you to rewrite this back as an exponent. So when there is nothing here in the root sign, it automatically means that it is a root 2. So when I have something like this, root 4, that means that I'm looking for the square root. So what number multiplied by itself will give me 4? So here I have a 2 inserted in there, although it's not there. And it's by default that we know that if there's nothing there, it means that it's the square root. So what this actually is p raised to the power of 5/2. This next one would be a raised to the power of 3/5. It's like saying the 5th root of a raised to the power of 3. And then the next one would be, okay, so we're going to take different steps here. So it would be 1 over x raised to the power of n over x, but because it's in the denominator, I want to bring it back up to the top. So I could bring it up to the top. I don't have to, because that would give me a negative exponent. So I could leave my answer like this, that I'm circling, or I could bring this all up to the top and turn it into negative n over x. All right. We've got one more page to go, and this is it. So I am going to take a look at this, and we're going to do 4. So we're going to simplify our answers here. So we're going to do 4 raised to the power of 1/4 times 8 raised to the power of 1/5. Now, I cannot add these exponents together because my bases are not the same. But what I can do is I can bring the bases down to the same prime number base. So that means that 4 could really be written as 2 squared, which is raised to the power of 1/4, and 8 could be written as 2 raised to the power of 3, which, again, is going to be raised to the power of 1/5. Now, when I simplify this, it will go to 2 to the power of 2/4 times 2 to the power of 3/5. And now here, I need to get a common denominator, which is going to be 20 at this point. So it'll become 2 to the, getting a common denominator of 20, so it would go to 10 over 20 plus 12 over 20. So that my final answer would go to 2 to the 22 over 20. That would be my solution there. Now I can reduce that down to 2 to the 11 over 10. And that would be my solution there. My next example, we're almost done here. My next example would be to do a power to a power. So I can do a to the 3/4, b to the 2/4, and that would be multiplied by a to the 3/12, b to the 3/4. Okay, so now I've got a to the 3/4, I've got a to the 3/4 times a to the 3/12, and it's multiplied by b to the 2/4 times b to the 3/4. So all I did was I brought together all the like bases, and now again I have to get a common base, or a common power. So I need to get the same denominator. So I get a to the 9/12 times a to the 3/12, and that's multiplied by b to the 5/4 because they have the same denominator there already. So I added my numerators. So now when I do 9 plus 3, that goes to 12. So I've got a to the power of 12 over 12 times b to the 5/4. So my answer is a, b to the 5/4. All right. One last example where all we need to do is simply just put the answers in radical form. So I'm doing 2 to the power of 1/3 times 7 to the power of 1/3. Now in this particular case, I'm going to be doing 2 times 7 raised to the power of 1/3 because we have the same exponents. Then we can multiply our two bases together so that our answer will go to 14 to the power of 1/3. I just want to reiterate, and I'm going to leave the last two questions. I want to reiterate this point. This is a law that's quite important that maybe we don't discuss enough. But if I have a to the m times b to the m, if I do a times b, because they are to the same power, then I can multiply my bases together and raise them to the power of m. So for example, I could have 2 to the 3rd times 4 to the 3rd, and that would give me then 2 times 4 all raised to the power of 3, and that'll give me 8 to the power of 3. And then that's whatever that answer is, and then I'm not going to sit and do this right now. Okay. So let's just do one more example over here, and then I am going to finish and end it off here. So if I have, let's do number 5, which seems to be the more complicated one. So I'm just going to do number 5 here. I'm just going to move this over. Okay, so that I'm going to work on this last problem. So I've got x to the 1/4 y cubed all raised to the power of -1/2, and that's divided by x to the 1/3 y to the -1/4 raised to the power of -5. Okay, so working this problem out, I'm most likely to do this. I'm most likely to do x to the 1/4 y cubed. Let me just rewrite that. X to the 1/4 y cubed, and that's raised to the power of -1/2, divided by x to the 1/3 y to the -1/4, and that's raised to the power of -5. So in doing this, I'm going to bring the top part down to the bottom and the bottom part up to the top because I really want to get rid of those negative exponents of -1/2 and -5. So I'm going to flip these around so that this will go up to become positive and this will go down to become positive. So it'll become x to the 1/3 y to the -1/4 all raised to the power of 5, and that's divided by x to the 1/4 y cubed all raised to the power of 1/2. Now in doing that, we can now simplify. So it becomes, and we're going to do a power to the power rule, so it becomes x to the 5/3 y to the -5/4 all divided by x to the 1/8 y to the 3/2. All right, now I'm going to bring my -y down to the bottom, and I'm going to subtract here, so I need to get common denominators. So that's a bit of a drag because I need to get a common denominator. So I'm going to do x to the 5/3 minus 1/8, and that's going to be multiplied by y to the -5/4 minus 3/2. I've decided to not bring the -5/4 down. I'm just going to subtract it. So this becomes now getting a common denominator. The common denominator here will become 24. So it's x to the 8 and 8 gives me 40 over 8 minus, and I multiply top and bottom here by 5, minus 5 over, wrong. So it's x to the 5/3 minus 1 over 8. The common denominator is 24. So top and bottom here gets multiplied by 8. So it's 40 over 24 minus 3 over 24, and that gives us x to the 37 over 24, and that gets multiplied by y to the, and let's get this as y to the negative 5 all over 4 minus 6 over 4, which gives us negative 11 over 4. Now the final step that I need to take is just bring that y to the negative 11 over 4 down to the bottom, so it becomes x to the 37 over 24 all divided by y to the 11 over 4. And I'm done. Okay, your work to complete here is going to be on Power School, but it is all here. We'll be completing this work in class. So I'll see you next time.